Hi, welcome back. In the last video, we reviewed how triangles can be classified by both their sides and their angles. Okay, and then I know the information that we're looking at, my triangles are to scale. Okay, so here I have a couple of examples, and then we'll do a couple on our own. So this first one says this is a right scaling triangle. So I know that I have a right angle, and I know the three sides must be different because it's scaling. The second one says it's an equiangular equilateral triangle, and I know it's equilateral because I can see 10, 10, 10. And then anytime you have a triangle that's equilateral, it will also be equiangular. That's always just going to work out that way. Okay? All right, now this is an interesting picture. So when we looked at it in the last video, it did tell us that our triangles were to scale. This one does not tell us that these triangles are to scale. So when I look at this triangle here, I do see that I have a tick mark here and I have a tick mark here. Okay, so I do know that I have two congruent sides, so I know we're definitely at least isosceles. And then if I were to measure this angle, if I line this up, I can see that this angle opens all the way up past the 90, right? It goes past the 90 and opens up to between the 100 and 110. So if this picture is to scale, this is obtuse. So it would be an obtuse isosceles or isosceles obtuse triangle. However, there's nothing here that tells me this is to scale, so I can only call this isosceles because I don't know if this picture is to scale, so I can only go with what is marked in the picture. Okay? So then when I look at this one, I have kind of the same situation, right? I only have the two sides that are marked. Okay? I only have the two sides that are marked. So when I look at this one, I know we're isosceles because these two are the same. And I bet you if I measure, I bet those are all acute angles. If I line this one up here, that angle is going to land right here between the 30 and the 40. And then if I line up here, this angle here is going to be less than 90. It's going to come up between 70 and 80. And then this one is going to come up also between 70 and 80. It looks like it's right there at 75. Okay? So if this picture is to scale, then this is isosceles and acute. But there's nothing that says in the directions here, this is the top of my paper, that says these triangles are to scale. So I can't call this isosceles acute because I don't have enough information. I can't call this one isosceles obtuse because I don't have enough information. Okay? If this hadn't told me it was scaling, then this one I could only call right. Okay? However, this one, even though I only have information about the sides, I can call this equilateral and equiangular because all equilateral triangles are also equiangular. Okay? So just be really careful. Even though this does have two classifications, we only have enough information to give them one classification. Okay? All right, let's look at this one here. Can you draw an obtuse right triangle? Yes or no? What do you think? An obtuse right triangle. No. And then let's explain. Why can't we draw an obtuse right triangle? Okay? Because the triangle, look what would happen. If I have an obtuse angle, something bigger than 90, and then if I have a 90-degree angle, my three sides, I would need a fourth side, right? The triangle won't close. I need a fourth side. And if I have a fourth side, we're no longer a triangle, right? So if I have an obtuse angle and a right angle, I'm not going to be able to close. Okay? Number 2, can you draw a right isosceles triangle? Well, let's see. Let's see if we can draw one. Let's go with just 1 inch, right? If I go 1 inch, 1 inch, And then from one of those ends, I'm going to make a right angle mark. So I'm just going to come here, line it up, and I'm going to put a little dot right above my no. And then I want a 1 inch. 1 inch. I'm going to line up this way. Just like this. And I'm going to go 1 inch. I'm going to go on top of some of my words, but I want to make sure it's... So this is 1 inch. This is 1 inch. I used my protractor to measure a 90-degree angle. And so all I have to do now to make this a right isosceles triangle is close it. So can you draw a right isosceles triangle? Yes. Do you remember what we call these two sides of that are next to the right angle? We call them the legs. Can be equal. So I have a right isosceles triangle. Okay? And then the last one there, can you draw a right equilateral triangle? So a right equilateral triangle. Think about what you learned about right triangles. And specifically, if these are my legs, right? I know that this would be my hypotenuse. And you learned, hopefully you remember, that we learned the hypotenuse is always longer than the other two legs. So can you draw all three of these sides if you have a right angle, which means you have a hypotenuse? Can your hypotenuse equal the two legs so that it's equilateral? No, right? So I have to say no, because the hypotenuse is always longer than the legs. Okay? All right. Then we're just going to do a couple little quick always, sometimes, never. So let's look at those. All right, number 4, a right triangle is isosceles. Always, sometimes, or never. Okay? So a right triangle is isosceles. Well, we can see it can be, right? Here's a right isosceles triangle. But look right up here. Here was a right scalene triangle. So a right triangle is isosceles sometimes. It doesn't have to be isosceles, but it can be. An obtuse triangle has 3 obtuse angles. Okay? So if I have an obtuse angle, and then I have another obtuse angle, and then I have another obtuse angle. Like, I can't have 3 obtuse angles and have a triangle. You're not going to close, and I ended up with 4 sides, right? So obtuse triangle has 3 obtuse angles? Never. Okay, and remember that was part of our notes, right? In an obtuse triangle, we said there is 1 obtuse angle. Just like in a right triangle, there is 1 right angle. And then in my acute triangle, that's the only one that has 3 of its description. It has 3 acute angles. All right? And then the last one, an equilateral triangle, is isosceles. And we talked about that already in the notes. The definition of isosceles is at least 2 congruent sides. And an equilateral triangle does have at least 2 because it has 3. So this one is always true. All equilateral triangles are also isosceles. All right? So hopefully this little quick review has reminded you about classifying by sides and classifying by angles, and added the new vocabulary word, equiangular, and then also reminded you that you can't make assumptions based on your pictures. Even though it looks obtuse and it looks acute, I don't have that information, and this doesn't tell me that this picture is to scale, so I can't assume that it is. So keep that in mind. That's very important for your assessment. All right, good luck on your assessment, and thank you so much for watching.